Hello, welcome to the Sleepy Brain Science. I'm so glad you found your way here tonight. Maybe the day was long and loud, and your body is only now beginning to remember what stillness feels like. Or maybe you're someone who has always found comfort in the quiet enormity of space. The idea that out beyond everything you know, there are worlds spinning slowly in the dark, minding their own beautiful business. Either way, you're exactly where you're supposed to be. There's nothing you need to do right now, no decisions to make, no messages to answer, just this soft voice and the slow turning of distant planets. Let your shoulders drop, let your jaw unclench. Feel the weight of your body pressing gently into whatever is holding you. Because tonight on Sleepy Brain Science, we're going on a quiet journey through our solar system. Not the textbook version, not numbers and test questions, but the strange, poetic, almost unbelievable version. The one where diamonds fall like rain, and moons hide secret oceans, and the sun itself hums like an instrument no one can hear. We'll take it slowly, one soft fact at a time. You don't have to remember any of it, just let it wash over you. And if these nighttime journeys help you rest a little easier, if Sleepy Brain Science has become part of your wind-down routine, consider tapping the like button and subscribing before you drift off. It helps other tired minds find their way here too. Now, let's begin. Neptune is the windiest planet in the solar system. You might expect the most violent weather to be found somewhere close to the sun, somewhere hot and churning, but the wildest winds in our entire solar system belong to Neptune, the farthest planet from the sun, a world of deep blue cold. Neptune's upper atmosphere is swept by winds that travel faster than 2,000 kilometers per hour. That's faster than the speed of sound on Earth, faster than any hurricane that has ever touched our shores. And yet, Neptune receives barely any sunlight at all. Scientists believe these ferocious winds are fed not from the sun, but heat rising from deep within the planet itself, leftover warmth from its formation still slowly bleeding outward into the dark. From the outside, Neptune looks serene, a smooth, pale blue marble floating in the void. But inside its clouds, something relentless is always moving. Mars carries a canyon the size of a continent. If you could somehow stretch out across the surface of Mars and walk due east, you might spend months crossing a single canyon. Valles Marineris is its name, a wound in the Martian crust that stretches more than 4,000 kilometers from end to end. It would swallow the entire width of the United States and still have room to spare. In its deepest places, the canyon plunges more than 7 kilometers down, 5 times the depth of the Grand Canyon. And unlike our canyon, carved patiently by a river over millions of years, Valles Marineris likely tore open as Mars's crust cracked and separated, the way ice fractures on a frozen lake. It sits there now, vast and silent, slowly filling with dust, a scar left by forces that have long since gone quiet. Venus lost its shield. Earth and Venus are almost twins, nearly the same size, nearly the same mass, formed from the same ancient cloud of gas and rock. And yet they became completely different worlds. One of the key reasons is something invisible. Earth has a magnetic field generated deep inside its core, where molten iron churns in slow churning flows. This field wraps around our planet like an invisible shell, deflecting the radiation and charged particles streaming from the sun. Venus has no such shield. Its core appears to be too slow, too still to create that kind of magnetic dynamo. So, for billions of years, the solar wind has blown freely against Venus's atmosphere, stripping away lighter gases, boiling off what might once have existed there. Venus may have once looked something like Earth, but without its shield, it became something else entirely. A world of crushing pressure, acid clouds, and heat enough to melt lead.
It may be raining diamonds inside Uranus and Neptune right now. Deep inside the ice giants, Uranus and Neptune, something extraordinary may be happening. Something that sounds like it belongs in a fairy tale. Both planets contain thick layers of methane gas, but beneath their cloud tops, pressures become so immense, temperatures so extreme, that scientists believe the methane can be crushed apart. Carbon atoms, freed from their molecular bonds, compress under the weight of everything above them and crystallize into diamonds. And then they fall, slowly, through the dense atmosphere, drifting downward like a glittering, impossible snow. Laboratory experiments have recreated the conditions needed for this process and watched it happen, which means that right now, as you lie here in the dark, tiny diamonds may be raining through the interior of a planet 4 billion kilometers away. Earth moves in a way no other planet does. Beneath your feet, the ground is moving, not fast enough to feel, but over millions of years, entire continents have shifted, collided, and drifted apart. The floor of the ocean is constantly being remade. Mountains rise and fold. Carbon dioxide is swallowed and released. This is plate tectonics, and as far as we know, Earth is the only planet in the solar system where it happens. Mars has volcanoes, but they no longer move. Venus has ancient highland regions, but its surface is frozen in time. Only Earth keeps shuffling its deck over and over, regulating its temperature, cycling nutrients, and giving life the conditions it needs to keep going. The restlessness beneath your feet is part of what makes everything above it possible. Some asteroids have their own moons. Out in the asteroid belt, that wide ring of rocky debris between Mars and Jupiter, most asteroids drift alone, but some of them have company. In 1993, a spacecraft called Galileo was passing through the belt on its way to Jupiter when it spotted something unexpected. A small asteroid called Ida, orbited by an even smaller object that came to be named Dactyl, a moon around an asteroid. Since then, astronomers have found dozens more. Some asteroids have 2 moons, some travel in pairs, each orbiting the other in a slow gravitational waltz. They're tiny systems, quiet and unhurried, held together by nothing more than gravity, the universe's oldest kind of affection. Mercury breathes in a way. Most planets hold their atmospheres tightly, wrapped in blankets of gas too thick to escape. But Mercury cannot do this. Its gravity is too weak, its surface too exposed to the solar wind. Instead, Mercury has what scientists call an exosphere, a thin, ghostly shell of particles that barely qualifies as an atmosphere at all. Sodium, potassium, oxygen, atoms blasted loose from the surface by impacts and radiation, drifting briefly through space before escaping entirely. They're always leaving, they're always being replaced. The surface gives a little of itself to the void, and the void takes it. It's not really breathing, of course, but it's the closest Mercury comes to it. The Sun is losing itself 4 million tons at a time. Every single second, the Sun converts more than 4 million tons of its own mass into energy. In its core, hydrogen nuclei collide and fuse into helium, and in that transformation, a tiny fraction of matter becomes pure light, pure heat, the warmth on your skin on a summer afternoon, the photons that grew a field of wheat, the energy that built everything. This has been happening for about 5 billion years. It will continue for roughly 5 billion more. The Sun won't run out of hydrogen tomorrow, or in our lifetimes, or in anything we can meaningfully imagine. But it is running out, very, very slowly, giving a little of itself away with every moment that passes. It is, in its way, endlessly generous.
Saturn's rings are disappearing. When you look at Saturn through a telescope, the rings seem so permanent, so elemental, as if they've always been there and always will be. But they won't. The rings are slowly falling inward. Charged particles and ice grains follow the planet's magnetic field lines and drift down into the upper atmosphere, where they vanish. Scientists studying data from the Cassini spacecraft estimated that this process, called ring rain, is happening fast enough that the rings could be gone in as little as 100 million years. And the rings themselves may be surprisingly young. They might have formed only a few 100 million years ago, long after the dinosaurs appeared on Earth. We exist, it seems, in a rare and lucky window, one of the brief moments in the solar system's long history when Saturn wears its rings. We get to see them. That seems worth pausing on. Martian dust storms can swallow a planet. Mars is red because it's covered in fine iron-rich dust, and sometimes that dust decides to move, not just in small gusts, but in storms so vast they eventually cover the entire planet. A Martian dust storm can begin as a simple eddy in the thin atmosphere, but heat and wind can feed each other, accelerating the storm as suspended dust absorbs sunlight and warms the air around it, pushing more air into motion. Within weeks, the red dust can blanket everything, blocking out the sun, chilling the surface, and turning the Martian sky from its usual pale orange to a flat, murky brown. In 2018, one such storm silenced the Opportunity rover, which had been quietly exploring the Martian surface for 15 years. Its solar panels filled with dust, its batteries drained, and it never woke again. Scientists listened for its signal for 8 months before finally saying goodbye. Europa may be hiding an ocean. Jupiter has many moons, but one of them keeps drawing our attention back again and again. Europa is covered in a shell of ice, cracked and ridged and stained with faint reddish streaks. Beneath that ice, the evidence is increasingly compelling that a vast liquid ocean exists. Not a thin layer, but a deep, dark sea that may hold more water than all of Earth's oceans combined.
It stays liquid not because of sunlight. Europa receives very little of that, but because Jupiter's immense gravity constantly squeezes and flexes the Moon's interior, generating heat. The tidal kneading never stops, and in that hidden ocean beneath kilometers of ice, where no sunlight has ever penetrated, there may be something alive. We don't know. We haven't been able to look yet. But the ingredients are there. Water, heat, chemistry, everything we know of that life requires. It is one of the most tantalizing questions in all of science, waiting quietly under the ice. Olympus Mons is so tall it's above the atmosphere. The tallest mountain on Earth is Everest, at about 9 kilometers above sea level. People have stood at its summit and struggled to breathe in the thin, cold air. On Mars, Olympus Mons rises nearly 22 kilometers above the surrounding plains. It is not just the tallest volcano in the solar system. It is so massive that if you stood on its outer rim, the curvature of the planet would hide its peak from view. It is wider than the state of New Mexico. It grew so enormous because Mars has no plate tectonics. On Earth, the crust moves over volcanic hotspots, which is why Hawaii is a chain of islands, each one formed above the same hotspot, then carried away. On Mars, the crust stayed still, and the lava piled up in the same place for hundreds of millions of years, building higher and higher. Olympus Mons is the patience of geology made visible. Saturn's rings are thinner than a skyscraper is tall. Those rings that stretch nearly 300,000 kilometers from end to end, an almost incomprehensible distance, are in most places less than 100 meters thick. 100 meters, about the height of a modest office building. Imagine a sheet of paper stretched across a basketball court and you're closer to the right proportions. Turn that sheet sideways and it almost vanishes. The particles in the rings are made mostly of water ice, ranging from tiny grains to boulders the size of houses. They're kept flat by Saturn's gravity and gently herded by shepherd moons that patrol the ring edges. Up close, the rings are not solid at all. They're a slow, sparkling cascade of ice, each piece following its own orbit, never quite touching.
Earth is the heaviest planet for its size. Jupiter is massive. Saturn is enormous. But if you measured how much mass is packed into each cubic centimeter, the true density, Earth wins. Our planet is the densest in the solar system. This is because Earth is rich in iron and other heavy metals, concentrated in its core through billions of years of differentiation. Heavy elements sinking inward, lighter ones floating up. The result is a world that punches above its weight, gravitationally speaking. That dense iron-rich core is also what powers Earth's magnetic field. Liquid iron flows in slow convective currents around the solid inner core, and those movements generate the magnetic field that shields us from the sun. Earth's heaviness is part of its protection. The sun is constantly ringing like a bell. Inside the sun, vast rivers of hot plasma rise and fall, driven by convection. These movements create pressure waves, sound waves essentially, that travel through the sun's interior, bouncing and echoing off its different layers. We can't hear them, they're far too low in frequency, and space carries no sound anyway.
but we can detect them by watching how the sun's surface rises and falls ever so slightly as the waves pass through. Scientists call this field of study helioseismology, the seismology of the sun. By mapping how these internal ripples move, researchers can reconstruct what the sun looks like far below its visible surface, the way a doctor uses sound waves to look inside a body. The sun is always singing. We've simply learned, slowly, to listen. Venus spins backwards and slowly. In our solar system, most planets spin in the same direction they orbit the sun, the same direction the sun itself rotates, but Venus goes its own way. Venus rotates backward. On Venus, the sun rises in the west and sets in the east, and it does so with extraordinary slowness. A single day on Venus, one full rotation, takes 243 Earth days. Meanwhile, Venus completes its orbit around the Sun in only 225 Earth days. A year on Venus passes before a single day ends. You would age a full year before ever seeing the sun set. The reason is still debated. Perhaps a massive collision long ago reversed its spin. Perhaps tidal forces from the sun gradually flipped it over eons. Whatever the cause, Venus keeps its own time by its own rules. Mercury hides ice in the dark. Mercury spins slowly, and it has almost no atmosphere to distribute heat. The side facing the sun reaches temperatures hot enough to melt zinc. The side facing away plunges to extreme cold. And at the poles, where certain craters are so deep that their floors never see sunlight at all, not once in the entire history of the planet, it is cold enough for ice to persist. These permanently shadowed regions are natural freezers, and spacecraft observations have confirmed what once seemed impossible. Water ice sits at the poles of one of the hottest planets in the solar system. The ice may have arrived with ancient comets or seeped up from beneath through long-forgotten volcanic activity. However it came, it stayed, tucked away in the dark, patient and still as Mercury burned overhead.